let's look at process innovations when we have three baristas. So we've looked at the base case where each barista serves an independent arrival stream. And if I wanted to assess performance with the training, which reduces their standard deviation from 83 seconds down to 8.3 seconds, that's a 90% reduction. I could do that by simply coming in here and changing that standard deviation. So let me just click on that and make that 8.3. So just to be clear about the setup here, we have these separate arrival streams for each of the baristas. As in the base case, these folks are independent. They're serving a different subset of the tables in the cafe, let's say. And these arrival processes are all 26.4 per hour. And all the service times have a mean of 87.6 seconds and a standard deviation of 8.3 seconds. So 87.6 and 8.3 across the board. And all I need to do, because they're independent and identical, I'm just going to analyze one of these. So all I needed to do relative to the base case to analyze the situation where you've got the base case, but with training in place, is to adjust the standard deviation down to 8.3. So let's clear that and then just run it, and we'll run it twice just to get a sense of how that happens. So I'll do this relatively quickly, just to get the 2 runs in. You probably need to do 3 to 5. A lot of it's going to depend on the variability that you're seeing in the results. So now I'm going to simulate for 108,000. Probably want to go as high as we can without exceeding the. So hit enter, make sure your number is in red up there, and then just hit go. And here the numbers run. Now, interestingly, in this particular simulation, the truncation is not a problem because your service time distribution is centered at 87.6 and the standard deviation is only 8.3. So you're miles from zero. So there's very little mass, probably mass down the bottom here. And the numbers that you're getting here is going to be almost an exact match with what you're seeing in the simulation, which it is in fact 2.78 minutes is what I think I got in one of the calculations with a calculator, with a queuing calculator. Okay, so that is our first simulation. How many did we get? 47,512. So maybe we could go a little higher than 108,000, but this is certainly a solid result. Let's go and redo this. So we go into run configuration, and I'm looking for. Sorry, it's simulation main. Yeah, and then there's this randomness piece here. And I need to just expand this to the point where I can change this to just any other number. I'm going to just try 67, let's say, just literally any other number. Just to kick off these random number generators in a different spot. So my previous result, waiting time of 87.6, of 2.78 minutes. I'm going to just see if that holds up in a second run again. You can go longer than that. I'm going to run this to completion. $47,000 got 2.8 instead of 2.78, pretty close. And then notably, I also got 64% utilization, 64.8 in fact, utilization on the on the resource pool on each barista. So each barista's busy serving coffee at 64% of the time. Okay, so that is the training. Now, I want to just show you in one run if you decide to automate. I'm not saying anything about the merits of taking the baristas out and replacing them with machines, but if you did want to investigate this, you could go and just make this a 0, because presumably the machine is not at all variable. And we'll just run this one time. You can see that 8.3 and 0 are pretty close. So the results are going to be close to what we've just seen with the trained baristas, but I just want to just demonstrate this option one time. So we'll go and do 108,000. Get it to run. And there you have it, 277, very close to what we've just seen with the trained baristas, because the standard deviation is very close, 64% utilization. So that's an automation option. Now, if you want to look at, I'm going to leave the trained baristas in place, but I'm now going to pool the order stream. So now the setup is this. We have arrivals, 26.4 times 3, because we're lumping all the orders together. And then, we assign these customers to whoever is available. They get served by the same baristas. They're trained now. So the means are 87.6 and the standard deviations are 8.3 across the board. This number here ends up being 78.9. All right, so that's an arrival rate of 78.9 per hour. So to analyze this setup, I need to change the arrival rate to for the lumped arrival rate, the 26.4 times 3, because I'm putting all the order streams into one. So 78.9. The service time remains the same at 87.6. Just confirm we've got that. There it is. We're saying that we're going to pool, the orders, and we're going to have the trained baristas. So let's put that in at 8.3. You could have them untrained. You could also analyze that easily enough. And then the number of servers critically is now 3, right? Because we're pulling these 3, especially pulling the baristas. And then I go ahead and run this. And again, you need to run it 3 to 5 times to adequately assess performance. Here, because the baristas are trained, the truncation issue is not going to affect our results. We're going to get results that are very close to the queuing model. If they were untrained, we are going to get a discrepancy between the queuing analysis and the simulation analysis. So I want to run this out. Now, notice that I have to run this for a shorter period of time, because my arrival rate is now 78.9 per hour. So I have 50,000 divided by 78.9. It's going to come out at about, what should I say here, about 6,000 hours, let's say. So I'm going to work with, let's say, it's a third of 108,000, 33 plus, let's say 3. So let me just put in here 36,000. But you have to adjust this because the arrival intensity is higher. And let's just run this to completion. All right, so I ended up with 47,000 customers. I want to get that to 50,000. And then my waiting time in system is at 1.76, and my utilization is at 64%. Again, you'd have to run this a few times to make sure that these results are consistent. When I did this particular setup on the queuing calculator, just want to see this. Yeah, I got something very similar. I got, I think, 176. This is 176. It's a good match. So very consistent when the truncation issue is not an drastic approximation. And that's only going to be the case if you're using untrained baristas in your scenario. Okay, so I hope you enjoyed this one. In the final clip, we're going to go and look at a 2 barista solution and just run through pretty much these same options.